As we dive deeper into the realm of cellulose, new and unexpected applications have emerged, showcasing its vast potential. In the bioptic project Ceres, scientists are harnessing the unique properties of cellulose to design optical fibers for biomedical applications.
They probably can't replace the classic optical fibers, which have a very small attenuation and you can transmit the signal for tens of kilometers. But there are lots of small-scale applications, for example, for sensing information from the tissues to outside world. So there one doesn't need to have tens of kilometers signal transmittance, but perhaps this length from the tissue beneath the skin to some sensors.
The use of cellulose for this highly demanding application is possible thanks to the internal structure of the fiber.
The transmission principle inside the cellulose fiber is pretty much the same as in any other material. So light is transported through a phenomenon called total internal reflection. So basically when you put light inside the fiber, it reflects from the interface between the fiber and the air and reflects back inside the fiber, and it just continues going on.
There are fossil-based solutions on the market, but cellulose can offer superior properties.
One benefit of cellulose is that it's very easy to chemical modify, so we can make totally new type optical materials that are not possible to do with synthetic materials.
This fiber can take humidity or water in the fiber. So the conventional glass optical fiber or polymer optical fiber, they cannot take water in. And the cellulose fiber also dries very fast, so we can utilize application where is this fast wetting and drying is needed.
And this is important because such fibers then can be used for measurements involving bodily fluid, for example, blood or sweat.
These unique features can provide a gateway to new applications where hydrophilic properties and biocompatibility are needed.
We have been working with a variety of applications with our cellulosic optical fibers. We have demonstrated spectroscopic measurements, we have demonstrated pH sensing, respiratory sensing, heart rate sensing, and in the future we are looking to develop these further and at the same time make our sensors reusable, for example in the case of pH sensing.
One of the most incredible discoveries has been the volume of data that can be transmitted within cellulose fibers.
We have shown that you can transmit optical signal with enough bandwidth to run 6 Ultra HD television channels in parallel. This demonstration shows that the potential of cellulose optical fibers is enormous.
The Bioptic team sees a solid road to commercializations, as these fibers can be considered a drop-in product to current wet spinning facilities for textile fibers.
Fiber spinning process exists in the textile industry for a long time for man-made textile fibers, and using a process that's very similar to that and just making some small modifications, we are able to spin these optical fibers. So the infrastructure exists already in the industry and it can be tuned actually to make our optical fibers in the large scale. We are just opening a completely new domain in this